it's a complex engineering process you have. How are you adopting AI into the process? Today, I have Chris Zuzik, all the way from United States. Chris, welcome to the Autonomous Vehicle Safety and Security Podcast.
Thank you for having me. I appreciate it. Happy Friday.
Happy Friday, yeah. So here are three things you should definitely know about my guest today. Chris has a pretty diverse background. He worked in investments and in manufacturing. So he has pretty diverse background from that aspect. That's number one. Number two, he was a coach in the high school soccer team where he delivered leadership lessons. I love that one. Maybe we should touch on that one a little bit. And finally, he's a golfer. So my first question to you is, I mean, the first point was you were already diverse in your career. Then we have soccer coach, leadership coach, and a golfer. How does that?
Well, I think the passion for me is manufacturing and leading teams. And I always feel that a successful leader gets the best out of people. And a leader needs to look at each person individually and say, here's my vision, here's where I think you could be. And then my job is to give that person the tools to be successful. And then it's up to them execute. And I learned that when I was coaching soccer, because some coaches take a blanket approach to their leadership or a blanket approach to their training, and they expect each person to react the same way. I learned relatively quickly that you have to look at each person individually and what their goals and objectives are. And as a leader, identify the things that can help them elevate their game or get to the next level. Or in my case, I would say, get the best out of people. So that was something that I learned very early on from a leadership perspective. And I've transitioned that into where I hope, if you ask my team, they would feel the same way, is that my leadership approach in what we do today as a contract manufacturing company is really help my teammates get to where they want to go.
Fantastic. And I think that's the perfect segue to, come to the topic that we want to discuss today. So as you said, you work in a contract manufacturing company, and actually you deal with metals, right? And today what we're going to talk about is in autonomous vehicle, connected vehicle, the implication of metal, because this is often undervalued part of the engineering. We call it dumb metal, but it's not quite dumb, as we will hear today. When things get so much connected, what is the implication of it, and what can go wrong in terms of safety security? This is the thing that we're going to talk about. Now, Chris, without further ado, my first question to you: what, as we talked in our previous conversation offline, the metal is not quite dumb. There are a lot of sophisticated engineering behind the metal that we use for a vehicle. So can you give us a very brief introduction so that we understand why it's not dumb, what kind of sophistication is needed, and why it's needed?
Well, and it's a very good point, because your connected car today from a safety or autonomous is a lot different than what it was 20 years ago. So you have a vehicle that's made up of a lot of different materials that are either protecting a computer or a module in a vehicle. And you're relying on that module to provide safety for that driver. So when you have a computer module in a vehicle, it's in a housing. It's an aluminum housing or a metal housing, primarily aluminum or stainless. But if you don't have material in the proper specification, let's say flatness, the effect of that computer can be minimized or maximized if that aluminum cover, for example, is not meeting a certain specification. So when that does happen, if the part is not met to a specific type of flatness specification or with an alloy that is expected, you have problems with the vehicle. And then, of course, it affects safety of the vehicle. So we as a contract manufacturing company, we're providing our customers a part that they've designed at a specific specification. But the special sauce, if you will, is not just making the part. Anyone can make the part. It's understanding that requirement of safety, that module, and then providing a part that's going to be repeatable, made the same way each time over and over again. So your material is a huge part of that, because if that varies, the whole process can vary. So it's very, very critical in a connected car, autonomous driving, to have materials that are made to specification, that are reliable and repeatable. And of course, lightweight also plays a role in some of the products that we're looking at today that are not in computers, but lightweights from seating parts to door panels, to whatever the case may be, your lightweight materials are obviously critical as well, especially based upon efficiencies in internal combustion engine, or in some cases where we're going from the EV world.
Got it. So there are two major things that we should to consider. One is the weight, the lightweight, and the second is the radio frequency or the connectivity part that will go through the metal.
Right.
Let's get into the second point, the connected vehicle, we're sending Wi-Fi signal, we're sending Bluetooth signals, we're sending GPS signals, we're sending I don't know, GSM signals. So there are enormous amount of data that is transmitted over the air, and it goes through the metal.
Right.
Right. So tell me, in which case metal is a problem for this kind of transmission or receiving.
Right.
And what do you do in your company to make them better?
It's a fantastic point, because whether it's an autopilot or whether it's an ADAS or autonomous, you have a module that is sending out those signals, right? So the protection of that module is critical. So what we look at from a metal perspective is we're looking not only at a specification requirement, but we're also looking at the types of material. So for example, we're looking at galvanized material that is less resistant to corrosion. Or in some cases, we have to use a metal that gets E-coated or painted, if you will, for additional protection. So you now are adding another variable to the part. You have your typical stamping or metal part, which has lubricants. Now you are getting into a part that is E-coated to protect not only the part, but also the module in the vehicle. So if you don't have the proper materials, i.e., let's say a galvanized or a proper E-coating, you can run into a situation where that part breaks down sooner than it should. And in the automotive industry, these programs tend to last 6-7 years, and the age of the vehicles last quite longer these days as well. So the integrity of that part, how it's formed, the type of metal, and any type of coatings on it is really critical to the success of that vehicle.
And we're talking about when you say a module inside your metal cover.
Yeah.
We're talking about also electronic components, right? Electronic control units, ECUs.
Right.
Fantastic.
Correct. And again, as a contract manufacturing company that is forming metal for complex assemblies, right? Our job is to look at that module, the ECU computer, and say, what is the outcome of that? What is our customer looking to accomplish today, tomorrow, in the future with this module? And making sure we work within the specifications or their design to give them a part that is going to protect that module for a long period of time.
So you receive the CAD design from the customer, and then you take the CAD to manufacturing.
Correct. And what we're doing a lot of times is before we even produce one part, we're making sure that we are in alignment with our customer with regards to the critical specifications of that part we're making for them to ensure, I guess I said before, repeatability, a zero defect, and a quality mindset, operational excellence. Of course, there's got to be a profit in it as well.
Understood. So let's get into the safety and security aspect of it. Let's start with safety. Now, I was talking to another company who we're also making cover, manufacturing cover, but they do plastic cover. You know, they're
Sure.
with the plastic. So what they were saying is they conduct FMEA for their products and stuff. How about you? Do you also conduct FMEA in your engineering?
Yeah, we'll go through the whole PFEMA, FEMA process as part of our APQP process with our customers. And I should state, we do provide our customers prototype parts that they will use as part of their modules in pre-production to test to make sure that there's no signal loss or whatever the case may be. So our advantage is that as a company, we have the ability to produce small run prototype parts before it goes into a stamping process, an example, or 3D model parts, depending, or a soft tool type parts to give our customers the advantage of testing things before they're actually installed in the vehicles.
So other than FMEA, what other safety aspect do you cover? Can you talk a little bit about the safety? What can go wrong in a cover?
Yeah, I mean, I think what can go wrong in some cases is that if you don't align properly with that customer expectation, let's say flatness is a critical aspect. If you have a part that's 3x3 and you form the metal, and for some reason you read the high level of the specification, and that flatness starts to give a little bit, that can cause potential interference. So what we're using from a safety perspective is using the SPC data as part of our ERP system, monitoring the trends of the tool to make sure and ensure that we don't go above that limit or don't go below that limit. So we put in place hourly checks, every 3-hour checks, depending on the part, to ensure that we're repeating that quality flatness as an example every single time we're producing a part. So we try to eliminate any of that risk that ends up at our customer's facility. Of course, they're doing their checks and balances too, but we have to meet a sprint specification to ensure on key characteristics that we're in specification.
Now, let's talk about extreme cases. Now, it's one thing to drive a vehicle in California, another thing to drive in the winter in the Midwest,
right?
Another thing to drive, in a extreme hot country like Africa or somewhere. Now, and I mean to just make it provocative. I mean, if you're probably driving the car in Norway, then you probably are facing minus 30 degrees, another extreme. So how does that affect your parts?
It's a great question. Obviously we're looking at our customers' design to make sure that we can manufacture it first and foremost. But if there are some certain specific requirements, let's say corrosion is a big part of it. What we do, because your point is very valid, driving a car in California doesn't have as much corrosion because they don't put salt on the streets like they do in the Midwest when it's snowing out. So corrosion is a very, very critical part that we look at and measure. So we'll work with our e-coaters to ensure there's a specific level of thickness of e-coat on that part on a regular basis to protect the part. And what they do and what we do is we'll go through some salt spray testing to identify any type of risk on the coating or the part prior to going to manufacturing. So we can give that information to our customer and say, this part, once it's stamped or produced by Waukesha, it's e-coated by another vendor, meets the requirements of the salt spray, so you don't have to run into corrosion problems.
Fantastic. Now, let's touch base a little bit on relevant standards. So, every industry had their relevant standard. In your case, is there any standard you guys adhere to, and what is that? And can you touch base a little bit?
The general standard, the general standard from our perspective is IATF, which is the automotive standard. Prior to that, it was ISO. But that standard of expectation is universal across our automotive customers. And quite frankly, it's transcending into other industries as well over the last several years. So that requires us to always be thinking our zero defect. Our processes and our practices have to follow a specific standard for the automotive industry. And what we do on a sometimes, well, it's daily, weekly, monthly, is we're doing our own internal audits to ensure that we're following those IATF standards. Not only do we do that in process, but every quarter, we review our goals and metrics to make sure they're in alignment with our expectations from an annual perspective, as well as our customers' expectations. And then within each customer, they also have their expectations or standards that they measure us and audit us on an annual basis. And it can be a VDA process as an example, where every year our quality is being measured and looking at from our customers' experts in quality. And we have to sustain that and exceed those expectations, whether it is, and again, IATF is looking at risk. Where are the risk potential? And how do we make sure we mitigate potential risks, whether it's cybersecurity, whether it's management of the supply chain, whether it's employee situations, or God forbid, if a building burns down, what happens from a risk? So we have to get measured on that on a regular basis.
Fantastic. So IETF is really the go-to
The governing, yeah, it's the governing part. Yeah.
That's the all right. One last question. You know, it's a complex engineering process you have, like
right.
standard-driven engineering process, a process-driven engineering, and then manufacturing. How are you adopting AI into the process? The reason I'm asking, you know, this has been like my my journey in the last 2 years, evangelizing the implication of AI, especially in engineering. So
absolutely.
How about you guys? What are you using so far?
Well, it's a great, and there's 2 areas of AI we're looking at, obviously from the customer side, but from the operational perspective, from the process side, is using AI to determine from a predictive perspective what is going to happen after, let's say, so many hits of that tool, right? And putting pieces in place that will give us the advantage of saying, hey, after this happens, you need to do this. And so predictive AI to us is that it really should give us an opportunity to take our ERP and then help us determine when we have to do certain things based upon X amount of hits, right?
Is it like when you say X amount of hits, it's like hit in the product itself when it's out, or in your engineering process? So
I would say both, right? We have to take a look at the history of a tool, as example, and using certain type of material that forming an X amount of part, and then saying, okay, that's going to last 8 million hits, okay? So from an operational perspective, using that to help us maintain the tools properly, but from an engineering proactive side, helping us design additional traits in the tool or maybe stations in the tool that we know may or may not fail based upon blank. Or in the case of using, I said before about, different coatings or e-coating, can we look at a part that has a certain thickness, and after a certain amount of time, we know we have to take a look at the eco process. So it's a combination of both. And I think, honestly, we're at the very, very early stages of using AI, but I think it provides an enormous amount of opportunity to improve our manufacturing process from an automation perspective, from a robotic perspective. And I think, quite frankly, AI also can help us look at making the right decisions with regarding adding labor or capital to address certain aspects of our business that maybe we don't know until it's too late.
Got it. And just to clarify, when you say 8 million hits, what exactly do you mean?
Good question. So if let's just say a tool is producing a part, and after 10 hits, after the material goes through, it's forming the metal, and after the 10th hit, it produces a good part. Okay.
What is a hit?
The hit basically is the material flowing through and the tool collapsing on the material to form the part in a certain way. So a part can be formed in 10 different stations, and at that last station where it gets cut off, you have a final part. So the first hit may be a form, the second hit may be a pierce, the third hit might be, or third station might be an idle, as it transcends through the part.
Got it.
Every time that tool is collapsing the material, okay, it's forming the material, which has an effect on that part of the tool. So after a certain amount of time, you have to sharpen, you have to maintain. Otherwise, if you don't do that, your final part is not what the customer expects.
Wow, fascinating. Chris, fantastic. It's a very insightful talk that we had so far. Thank you so much for being with us. It was wonderful having you, Chris.
I appreciate it very much.
So thank you so much for watching. So we will be doing more episodes like this, and I hope Chris will come back probably for another episode. So stay tuned. We'll be having super exciting talks like this. And if you have questions, comments, please write in the comment section. And subscribe or follow depending on wherever you're watching or listening to this podcast. Thank you so much. We'll see you in the next episode.